right, here we go. 4.5. Day 2. We're going to start with graphing y equals 3 sine x over 2. So you start with your amplitude. Remember, amplitude is the absolute value of the a value. It's also a distance, so amplitude cannot be negative. Even though a can be negative, the amplitude cannot be negative. The period is 2 pi divided by b, so 2 pi divided by 1/2 will be 4 pi. Okay, so this is the sine function. Sine starts at 0 and goes to the a value. If a is negative, you drop down first. Okay? All right. Next item, a phase shift. A phase shift is really your left-right shift. And so what I'd like us to do is once you get that jotted down, we're going to do a little exploration on the calculator. Oh, did you guys remember we were going to do a unit circle quiz today? So if you forgot, you can study during the time, we'll do it at the end. And I'll give you a few minutes beforehand too. Okay, everybody have this written down? No. No. The phase shift, phase shift. Okay, everybody got it now? Alright, so let's go to our y screen. And in your y screen, let's put sine x. And in y sub 2, let's do the sine, and we're going to do this one in degrees. Let's do x minus 60. And in y sub 3, let's do the sine of x plus 30. So I want to do this one in degree mode. So check your mode. I'm going to keep sending papers back here. So I'm going to check my mode, I'm in degree mode. Now do zoom trig. And something that was commented about in the earlier class is that just because you've put it in zoom trig before, that was in radians, so it's really zoom trig for radians. So you do need to do zoom trig again, okay? And then can you see where the parent function is? minus 60 moved it right 60. My x plus 30 moved it left 30. Also notice these are 90 degrees for tick marks. It's 90, 180, 270, 360, and so on. Okay, so that's what a phase shift is. That's your left and right. Okay, so let's look at one that has a phase shift. So if I want to graph y equals 4 cosine the quantity x plus pi over 4. I like to do these in 2 steps, and I know some of you last year when we did this, and we just did sine cosine last year. Tomorrow we're going to start 4.6 where we do cosecant, secant, tangent, cotangent. Some of you could do it in one graph, and if you can, terrific. I don't, so I'm going to show you the two-step method. Step 1 is you want to graph y equals a cosine the bx. Then you want to do the phase shift, the left-right, or the vertical shift, the up-down. Okay? So we're going to start with y equals 4 cosine x. I know my amplitude is 4, and the period is 2 pi. So I do this with two graphs. If you can handle one, that's terrific, and you can do it that way. I had to bribe my calculus class to sing today. I had to pay them with a candy bar. I videotaped them. We had calculus carols today, Christmas carols. They were good. All right, here we go. Cosine starts at A, so I'm going to start at 4, 0, negative 4, 0, 4. I'll continue it, and then if you remember from last year, what we do is we make a dashed curve. And that will represent the first graph. So you use a dashed graph. Step 2, do either your phase shift or what we're going to see in the next one is the vertical shift. So we'll put it here if you're looking at steps. So this one is moving left pi over 4. Do you remember the inside is the opposite? The inside is the opposite of what you want. Well, you need to look at what is a tick mark. So on this, and from graph to graph, it will change depending on the period length, okay? So each tick mark is different. What is the value of my first tick mark? It's pi over 2, but I want to move pi over 4. So how am I going to shift? Half of a tick mark, exactly. And so what you're going to do is you're going to look at each point, and you're going to move half of a tick mark left, like this. And there you have it. Again, if you can handle this in one graph and you can tell, okay, here's my amplitude, but I'm going to need to move left half a tick mark, you can do it with one graph. Is absolutely fine. I personally prefer the two. Makes a little bit more sense to me. Any questions so far? You guys remember this now? Is it coming back to you? All right, a vertical shift. A vertical shift is represented by y equals sine x plus d. Now that d is not inside with the x. It's not inside the sine function. And that's an up-down. Something I want to point out to you is your textbook, I'm not quite sure why, But they put the problems where they put the constant first. What I would recommend that you do is just take a quick moment and rewrite it. So then now you can see a little bit easier that that's the up, down 2. I don't know why they put it first. And if you see a subtraction, like 2 minus 3 cosine 2x, that means the amplitude, the A, is negative. There's a reflection going on there, okay? So maybe some of you saw it already if you started the homework last night. All right, so I'm going to do this graph in 2 steps. Step 1, I'm going to graph y equals 3 cosine 2x, and then I'm going to do the vertical shift. So this has amplitude 3, and the period is 2 pi divided by 2. When you're graphing these, I'm going to look and even ask for your amplitude, period, phase shift, I can speak, phase shift and vertical shift. So my 4th tick mark is pi. Half of that is pi over 2. Now you might want to do some forward thinking here as you're making your grid. On the first graph, I'm going up and down 3, but I can look ahead to know I'm eventually going to shift it up 2 more units, so I need to really go up to 5. Okay? So, if I plot 3 cosine 2x, that starts at the amplitude, so I'm going to start at 3. And then I go to 0, negative 3, 0, 3. I'm going to continue it left. Step 2, we have a vertical shift of up 2 units. And you may abbreviate phase shift as PS, and you can use a left-right arrow, and vertical shift VS, and you can use the up-down arrow. So all I'm going to do is take every single point that I plotted and move it up 2 units. And so your final one should be the one that's solid if you're doing 2. All right, the next one, I'm going to give you a head start on me. You guys ready? All right, try example 7 on your own. Let's see if you can do this. So while you're working, we are going to be finishing 4.5 today, so it's due tomorrow. Tomorrow we're going to start 4.6 and only get about halfway. So you will not have any formal homework over the break. When we come back, we'll do the second half and then you'll finish your homework then. I would encourage you though to work on your semester exam review packet. Hopefully you're partway into it now. I'll be in my fantasy world that you have started it. I'll pretend that. Some of you I think have.
Right before the test. Don't do it too early, or then you'll forget all the stuff you remembered.
Right.
It's always 2 pi divided by half.
You got to do it the night before.
Yeah,
That's a bit of a stretch.
I think you'll be in pain if you try the night before with all of that. It's a lot.
So it's 2 pi.
1 and it's sweet.
Yeah, so okay. Yeah.
So it's just 2 pi.
So remember, the amplitude is positive 3. I'm doing this in 2 steps. Okay, so this is sine. Sine starts at 0, but because a is -3, it drops down first. And then this one's a phase shift, right? This is right pi over 6. Huh, well wait a minute. What's 1 tick mark? Pi over 2, how are you going to figure out what pi over 6 is? It's a third of the way, isn't it? Well, some people don't quite see that. So, to get pi over 6, it's 1/3 of pi over 2. That'll give you your pi over 6. So if you didn't think of that, now that's in our tool belts. So make sure it's not at the halfway mark. You want to make it about 1/3 of the way to the right, okay? So that's a teeny, teeny, tiny shift. Okay? Okay, any questions on that one? All right, here's the last one. Try this one. If you need to rewrite it, rewrite it. All right, now this one has a phase shift right 3 pi and a vertical shift up 1. Okay, now 3 pi, that's a lot. To the right, considering the 2 tick marks, is pi. And I want to point something out to you, that you actually don't need to go all the way out to 5 pi. Is there anybody who has their thinking cap on? Josh, what do you think?
It repeats, so you only have to shift 1 pi.
Yeah, do you see that? That right 3 pi, because this does go on forever and ever and ever, right? And if I shifted right pi, that's equal to 3 pi, isn't it? Oh, okay. So, let's just do that. And then here's the other thing is, you could almost not even do that. What's going to happen is, if in the back of the book, what they like to do is they still like it to be within the negative 2 pi to 2 pi. A right pi is the same as left pi, isn't it? Isn't that a distance of 2 pi? Oh. That might be mind-blowing here, but so for now, we'll just move it right pi. So if I take this, that's now at 3 pi. So that's moving it 2 tick marks, right? Did I miss one?
Yeah,
You put one,
you put 2 on pi.
I did? Oh, I did. I'm like, wait a minute, this
Yeah.
isn't working.
Yeah, 6 to the right.
Yeah. Okay, that one over.
Like a woman, 6 over there, and 6 over.
Can
So
you put
this one is in the wrong spot. Okay. Okay. So this one, oh gosh, now I can't even see. Alright. So this one went over 2. This one went over 2. That one's in the wrong spot too. Okay. I kind of flubbed up on that one. Okay, so that one went over 2. And did I put that one in the wrong spot too? Wow, I got really off track right away. Woo! Okay, let's try this again. Then this one's here. That one's there.
Yeah,
That-
this is
There we go. Okay, here we go. Now I got it. Maybe. Okay, so no, that one's over. Yeah, that's okay. But do you see how they may have even continued it over here and then not had that? You can see how you can to do that.